So question number one, a student is determining the weight of a meter rule using a balancing method. So he's finding what is the weight of the meter rule using a balancing method. The apparatus in figure 1.1 is shown. A pivot is there at 45 centimeter mark. And P is there at 5 centimeter mark. The student places the load P on the meter rule at 5 centimeter mark. She places the meter rule on a pivot at 45 centimeter mark. She places a load Q so that the rule and adjusts its position so that the meter rule is as near as possible to being balanced. So that meter rule will be balanced. She measures the distance X between the center of the load and P and the center of the load P and the pivot, and the distance Y from center of load Q to the pivot. She repeats the procedure, placing a load P at 10 centimeter mark, then 15 centimeter mark, then 20 centimeter mark, and at the last 25 centimeter mark. So these are the values given. The readings are shown in the table for X and Y. For each value of X, calculate A, which is P multiplied by X, and where P is equals to 1, and record the value. So basically P multiplied by X, the formula is given that value of A is P multiplied by X, and value of P is 1. So 1 multiplied by X, here the value of X is equals to 40. So 1 multiplied by 40, it will be 40, 35, 30. Because when I multiply them by 1, the value of the X with 1, I'll get the same answer. Then for each value of Y, calculate By and calculate B, which is equals to Q into Y, and value of the Q is 0.8. So 0.8 into 4.25. What's the answer? 0.8 into 0.8 into 42.5. That is 34. So we'll write 34. Then 36 multiplied by 0.8. What's the answer? 28.8. Then 30 multiplied by 0.6. 18. 24, sorry, not 0.6, 0.8. 30 into 0.8. And 24 into 0.8. This was 24. So it is 34, 28.8, 24 is there. Then 19.2. Yeah. And the last value, 17.5 multiplied by 0.8. What's the answer? 14. So these are the values you will substitute. Then, yes, Salman, you have a question? Next, complete the column heading. What is the meaning of complete the column heading? Means the quantity and the unit. What is the quantity is written, but what about the unit? So how to work out the unit? As you can see, this one 45 centimeter and this is 5 centimeters. So distance between them is 40. And what are the unit of X? X is a distance. So what is the unit? Distance can be meter, millimeter, centimeter. How you can work out? All the values of X are given in centimeter. What about the values of the Y? Y is also in centimeter because Y is also a distance. This is a meter rule or a meter scale. If it was in meter, then it will be like 0.42, 0.36. So that is also centimeter. Then A is P multiplied by X. So what is the unit of the P? The unit of the P is Newton. And what is the unit of X? It is centimeter. So A is equals to Newton centimeter. What about B? B is Q multiplied by Y. Q is Newton and Y is centimeter. So Q is also B is also Newton centimeter. Is it clear? The column headings. Complete the column heading means the quantity which you are measuring and the unit. So the quantity is already mentioned. The quantity X is there, or quantity Y is there, or A is there, or B is there. And what are the unit? That is the column heading. Quantity with the unit. In the next part, what we have to do, we have to plot a graph between A on x-axis, is A on y-axis, and B on x-axis, and you can see the answer of A, the column heading for A and B is already given here. It is Newton per centimeter. Now I need the values. I will use those because I need a value to plot a graph, the previous values for A and B. So the value of A and the value of the B. So A was 40, 35, 30, 25, 20. And B is 34, 28.8, 24, 19.2, and 14. So for A, the maximum is 40, minimum should be 0 because they already mentioned you should start both the graphs from origin, so it should be 0. So if I select a scale, if this is 10, 20, if this one is 10, 20, 30, 40. So these are the values for A. What about value for B? The maximum value of B is 34 and the minimum, they've already mentioned you should start from origin, so minimum is 0. So if I select 10, 20, 30, like each box is equals to 1 and 40 and so on. This will be 50 and here this is also 50. So we have to plot a graph 40 and 34. So 40 and 34. For A it is 40 and for B it is 34. So 31, 32, 33, 34. So this is 40 and 34. 35 and 28.8. So 35 and 28.8 means close to 29. So somewhat here. 30 and 24. So 30 and 24, 30 and 4 boxes for x-axis. 1, 2, 3, 4. Then 25 and 19.2. So 25 and 19.2. So this is 19, a bit more than 19, 19.2. And 20 and 14. 20 and 14 is 1, 2, 3, 4. That's 14. Then what we do, we will draw a best fit straight line. Joining the points, that is our best fit straight line. Is it clear, the graph? Then, is it clear to everyone, the graph? This graph, they give very simple like values, so it was really easy to plot this. You have to join the points. It is not necessary that the line which is joining the point should start from origin. The idea is that when you're plotting a graph, like example, my points appear to be like this. I have to draw a line to join the point. It is not necessary that I should join the origin, because there is no value in the question in which A was 0 and B is 0. If A is 0 and B is 0, then my graph should start from origin. But because in the question no value is mentioned, they did not mention any value in which A is 0 and B is 0, both are 0. That's why you should not start from origin. You can just draw a line to join the points. Then use the graph, determine the vertical y-intercept. What is the meaning of y-intercept? In mathematics, maybe you have studied the formula for gradient as well as the concept of y-intercept. Like example, if this is our line, what is the meaning of y-intercept? When we extend our line, the point where this line intersect the y-axis, that point is known as y-intercept. And if the line was other way around, if this was a line and we extend the line, the point where this line cut the x-axis, that point is known as x-intercept. Yeah, y is equals to mx plus c, where c is the y-intercept. That's right. So in this question, we need a y-intercept dimension. And what is the meaning of y-intercept? Y-intercept means when b is 0, the quantity on x-axis is 0 and the quantity on y-axis is having a value. That is called a y-intercept. So what you will do, you will extend using a ruler scale, you will extend this line, straight line. The point where this straight line intersect or touch the y-axis, that point is known as y-intercept. So what is the y-intercept here? 1, 2, 3, 4, and 5. So what is our y-intercept in this question? Our y-intercept is equals to 5. Or if it appears 5 points, according to your graph, because it will have a range, 5.5, okay, 5.5 acceptable, 5 is there. It's according to the graph which you will plot. Is it clear? The y-intercept? So your y-intercept is appear to be 5. Your y-intercept appear to be 5. Then calculate the weight of a meter rule using an equation. Weight is equals to y divided by z. So you don't have to learn any formulas. All the formulas in the exam for paper 6 will be given. You just have to see y is equals to mx plus c. C is called a y-intercept. This C is the point where your graph line touch the y-axis. That's called C. So here y-intercept is 5 and we need W, which is y divided by z. What is the value of y? Y is kept 5. And what is z? That is also 5. So 5 divided by 5, what will be the weight? It will come out 1 Newton.
So they are giving the formula in the questions.
Yeah, paper 6, you don't, I told paper 6, you don't have to learn any formula. Paper 6 formulas will be given. You just have to use the values from either by measurement or by graph and substitute in the formula to get the answer.
So it's like mathematics.
Yeah, mainly that's why I'm saying paper 6 is not that difficult. It's just you have to go through 5 to 6 sessions of paper 6 and you will find it very easy.
Yeah, okay.
Then suggest one practical reason why it is difficult to obtain an exact result in this experiment. Like in this experiment, what practical difficulty you find? What might be a practical difficulty when you are doing this experiment? In part C, That's the y-intercept. When you plot your graph, you have the graph, and this was a line of your graph. So to get the y-intercept, what we did, we extend our line. Using a ruler scale, it should be a straight line. So the point where this line touch the y-axis, that is called the y-intercept. So you will substitute the value here in place of y. That was 5. And in part D, because the value of the y-intercept is 5, you need W. W is capital Y divided by small z. What is the value of capital Y? That is 5. What is the value of small z? That is also 5. So 5 divided by 5, that is equals to 1. Then suggest one practical reason why it is difficult to obtain the exact result. Basically, what is the practical difficulty in balancing experiment? First thing, it is difficult to balance a meter rule when there are load placed on it. Yeah, that's why, like maybe pivot moves, maybe the masses slide down. There are many factors. Any sensible answer is acceptable here. Commonly, you will find the common answer for these questions is the problem is it is difficult to balance when mass is placed or load is placed on meter rule, or you can mention meter rule slide down from the pivot, or the mass slide down when you're placing the mass. So many reasons are there, but commonly you will find that difficult to balance when mass is placed on it, on the rule. The student uses an accurate electronic balance to obtain the second value for the weight of the meter rule. He now look, student first, when student he use a balancing method and he's getting answer 1 Newton. Okay. And then student simply place this meter rule on the balance and he's getting answer 1.24. State and explain whether the two values agree within limit of experimental accuracy. Now, when you're comparing the two values, whether they are equal, what you can how you can compare, you can calculate the percentage difference between the two values. How to calculate a percentage difference? Percentage difference is a maximum value minus minimum value divided by mean into 100. That is a formula which you have to remember for calculating a percentage difference. You can even do this question by your understanding, by your estimation, like one of the values 1 Newton, another value is 1.24. What do you think? They are close or no? What, by looking at these values, so what it appear? So you will say two values are statement, you can say two values are close. So statement, you can say two values are approximately same, and justification, they have a small difference. That is one thing, that is your estimation. But there is also a method, calculation method. Using this calculation method, you can also work out and say your answer. How you can use the calculation method? By using a formula of percentage difference. So what is the formula of the percentage difference? Percentage difference is maximum minus minimum divided by mean into 100. If the percentage difference is less than or equal to 10%. If your final answer is 10% or less, it means you will consider they are equal. If your final answer is more than 10% for the two values comparison, it means you will say they are not equal. So if I calculate a percentage difference, so I want you to calculate the percentage difference. Maximum value, the two values, one is 1 Newton, another one is 1.24 Newton. What is the maximum value? The maximum value is 1.24. What is the minimum value? That is 1. Divided by mean. What is the average of these two values? 1.24 plus 1 divided by 2. What is the mean or average? 1.24 plus 1 divided by 2. So 1.12 is the mean. So 1.12 and multiplied by 100. What is the final answer? If answer is 10.1, it's approximately same as 10. When there's a difference, it will come out like 15, 13. What is the final answer after calculation? 1.24 minus 1 divided by 1. First you will subtract. When you subtract, it will come out 0.24. So when you subtract, it will come out 0.24 divided by 1.12 multiplied by 100. And you will find your percentage difference is coming out 21%. So your percentage, when you were estimating, you think that it was same value. So when you write your answer, you will write according to your value, because in the marking scheme, this answer, there is one expected answer. But for example, if student did a mistake in the first part, like student is getting this answer, for the weight, student is getting the answer 1.7, example. So if student is getting an answer 1.7, so he will compare his result with 1.7. That is why whenever you're writing an answer, you will compare your results. In marking scheme, there is a journal answer like expected answer. So expected answer for this one is yes, like it should be equal. But because our value is coming out 1, so our value does not matches with the marking. 1.24 does not matches with 1. They have a greater percentage difference. So when we are writing the answer, we will write no, the statement two values are not equal. And the reason is you will mention the percentage difference is more than 10. So keep in mind, this answer is not a fixed answer. It based on, even the examiner will check this answer according to your answer. Like another student perform this, and from his graph he's getting 1.2, or he's getting 1.25. So he's getting 1.25 and here 1.24. So when we calculate a percentage difference, it will come out less than 1, less than 10%. So we will say, yes, that student should write yes. So answer for this question is depending on the values, because you have to compare the two values. Is it clear? So don't bother about this type of question. It is totally based on your answer. In the marking scheme, expected answer is yes, like the two values should be closer. But because our answer is different, that's why according to our answer, two values are not equal. Question 2, a student is heating water in a beaker using electrical heater. He measured the potential difference V across the heater and the current. Write down the reading on the meters. What is the reading on voltmeter? 8.1 or 8.2? It is 8.2 because between 0 and 1 there are 5 lines, so each is equals to 0.2. Even a small, you will lose a mark if you write 8.1. What about this one? What about the current reading? So it is between, this is 0.4, this one is 0.5. So it is between 0.4 and 0.5. So answer for 0.44 or 0.5, both are acceptable. Even you write 0.44, that is acceptable because or 0.45 is also acceptable. Is it clear?
Yes, sir.
Then the next part we have to, he measures the temperature of a water before heating. Write down a temperature reading. What is a temperature reading? It is 19, so that is 19 degrees centigrade. The, then on a figure 2.3, draw a line and an eye to show clearly the line of sight required to read the volume. So whenever we read, we always read the lower meniscus for the water. So we will draw an eye and show the, or draw a line to show what we are reading. Is it clear?
Yes.
So that was only question 2. Like you just have to read the values. Question 3. The student is investigating the resistance of a lamp filament. The circuit is shown in figure 3.1. A supply is there, D. The student places a sliding contact C on the resistance wire. He places, this is a resistance wire and he's placing this is a sliding contact. What is the meaning of sliding contact? Means he can change the position of this. That's a sliding contact. And the distance is 0.2. He measured from A. He measured the current and voltage across the lamp. He repeated the procedure for 0.4, 0.6, 0.8 meter. Calculate the resistance R of a lamp for each set of reading using equation R is equals to V over I. So resistance is voltage divided by current, and you don't have to learn this formula. You just have to calculate this value. What is the resistance of the first in the first column? 1.6 divided by 1.
1.6.
That will be 1.6. 1.3 divided by 0.86. The second one, 1.3 divided by 0.86. 1.51. And when you write, look, each column should have same number of significant figure. Like you can see here, they're using 2 decimal places after point. In this column, they're using 1 decimal place. So if I'm using 1.51, so I should write 1.60. Even it is 1.6, but if I'm using a same, I should use for the same column, I should use equal number of decimal places. What about the third one? 1 divided by 0.74? 1.35. And what about the last one? 0.8 divided by 0.66? 1.21. Then complete the column heading. Complete the column headings in the table. This is a distance that is in meter, so we'll write m. V is the voltage, so we voltage denoted by the unit of voltage is volts denoted by V. Current unit is ampere denoted by A, and resistance you can write OHM, or you can write make a Greek alphabet here, omega, which is also used for resistance. The student notices that the lamp does not glow when he takes the final set of reading. He thinks that the filament has broken. State whether the student is correct and give a reason for that. Look, the values were 1.6, 1.51, 1.35, and 1.21. The last reading, he finds the filament does not glow. So student think that the filament, because it's a filament lamp, so if it does not glow, student think that this lamp filament is due to heating effect, the filament might be broken. Is he right or wrong? A student. The statement, it is wrong. State whether the student is correct. So student is incorrect. Why student is incorrect? Because if there was a broken filament, then there should be no current in the lamp. But still current is flowing. It shows that if there is a current, that means the filament is not broken, or circuit is not broken. No current in a broken circuit. Otherwise, this current should be 0. So statement, you will say no, because there is a current reading. In a complete circuit, current can only flow in a complete circuit. So what if there is a broken filament? If filament break from this point, then the current value should be 0. But still there is a current value. That is why it shows that the filament is not broken. So statement here, whether the student is correct. So student is incorrect. And what is the reason? That the current is flowing through the filament if it was broken. The current should be 0. So there is a current, there is a voltage, but that is not sufficient to supply enough power to light up this lamp. Is it clear? A student suggested that the resistance R of a lamp should be constant. Suggests, referring to the observation, why the resistance may not be constant. Resistance should be constant, like here 1.6, 1.5, 1.35, 1.21. Resistance should be constant, but here the resistance is not constant. What might be a reason? What can cause the change in the resistance? Filament lamp is, no, the resistance, even we change the, when we are changing the length, when we are changing the length of the wire, the voltage and the current which is there across the lamp, that is changing, but the ratio should be constant. But that ratio is not coming out constant. What might be a reason? The reason is because lamp will become hot. Temperature of, when we are changing this distance, voltage and current here is changing, but the resistance should be constant. But this resistance is not constant because of heat. The temperature of the lamp might change. That is why resistance is not constant. Increase in length increases the resistance, Salman. But in this question, we are changing the, this is not the lamp, this is a wire, metal resistance wire. When we use a longer wire, its resistance change. But we are not talking about the resistance of this wire. We are talking about the resistance of the lamp. So as the resistance of the wire changes, the voltage across the wire increase, the voltage across the lamp decrease. Voltage across the lamp will change, the current across the lamp will change, but the ratio of voltage and current across the lamp should be same. For metal wire, resistance and length are directly proportional, but they are asking about this filament lamp. Is it clear? Then name an electrical component that can be used instead of A and B, and the sliding contact. Basically, it's a variable resistor, because when we move the sliding contact, we can change the resistance of this A and B. So if we can change the resistance of the component, what we call, or what we can replace with, we can use a variable resistor. Then draw a circuit diagram, include this component. So we have to draw a circuit diagram. I will draw a circuit diagram next to this. So what we'll do, we'll have a, I will quickly draw because less than 1 minute left. Supply is there, a lamp is there, a voltmeter, and next to that is a variable resistor, and then ammeter. So basically this whole part is replaced by a variable resistor. Is it clear? The whole circuit, I forgot to draw the switch, but there will be a switch as well. Is it clear, this part?